Dear travelers of imagination, companions on this infinite journey through the mysteries of the universe, allow me to invite you to a deep and contemplative exploration through the most fascinating and enigmatic domains of the cosmos that surrounds us. I am the one who accompanies you on this starlit night, whispering cosmic secrets while we contemplate together the wonders that hide in the unfathomable depths of space-time. Have you ever lain down on a clear night, far from the artificial lights of civilization, and looked at the infinite canopy of stars stretching above your heads? Have you ever felt that sensation of cosmic vertigo? That sudden perception that you are part of something immensely larger and more mysterious than everyday experience can encompass? Today, in this intimate conversation under the starry sky, we will unveil one of the deepest and most beautiful mysteries that the cosmos holds in its heart: black holes. But forget for a moment everything you think you know about these invisible giants. Abandon the simplistic images of cosmic devouring monsters that popular imagination so loves to portray. They are not merely the universal vacuum cleaners that indiscriminately swallow everything. They are infinitely more complex, more elegant, more fundamental to the very existence of the universe than any superficial description could suggest. Black holes are the silent architects of the universe, the invisible sculptors of reality, the maestros of a cosmic symphony that echoes across billions of light years and extends through eras that transcend our temporal understanding. They are the guardians of the deepest secrets of physics, the teachers who instruct us about the fundamental nature of space, time, matter, and energy. Come with me, dive with me into this exploration that will take us to the limits of human knowledge and beyond, where science meets poetry and where our understanding of the cosmos transforms into reverence and wonder. Prepare yourselves for a journey that will forever transform how you see the universe. Prepare yourselves to discover that black holes are not voids, but infinite plenitudes, not endings, but beginnings. Not destroyers, but creators of the most sublime cosmic beauty. Imagine, if you can expand your minds beyond the limits of everyday sensory experience, a ghost that reveals itself not through its visible presence, but through the eloquent absence it leaves around it. Black holes are precisely this: invisible presences that manifest through the extraordinary effects they exert on everything around them. Like an invisible dancer in a cosmic waltz of unimaginable proportions, they conduct entire stars in elegant and precise orbits, revealing their existence through the celestial choreography they orchestrate with a mastery that transcends any human art. When a massive star, often dozens or even hundreds of times larger than our benevolent sun, reaches the end of its luminous journey through cosmic time, it doesn't simply extinguish like a candle that quietly dies in the night. Imagine a ballerina performing her final movement, spinning faster and faster, concentrating all her vital energy, all her essence, all her colossal mass into a point that becomes progressively smaller, denser, more intense. Gravity, that fundamental force that keeps you gently attached to the terrestrial ground, that governs planetary movement and determines galactic architecture, becomes so extraordinarily intense that not even light, that fundamental entity that defines our perception of reality, can escape its inexorable embrace. But here is the first profound revelation I wish to share with you, the first pearl of cosmic wisdom that will forever change your understanding. Black holes are not the indiscriminate cosmic vacuum cleaners that popular imagination so loves to portray. They are selective, precise, almost artistic in the sublime way they interact with the universe around them. If our beloved sun, that star that warms our days and illuminates our existence, were magically replaced by a black hole of exactly equivalent mass at this precise moment, you would not be instantly sucked into it like flies in a cosmic trap. Earth would continue its normal and familiar orbit, only deprived of the golden light and vital warmth that sustains life as we know it. The true magic, the true cosmic spectacle, happens when matter approaches what physicists poetically call the event horizon, that invisible and fundamental boundary beyond which nothing, absolutely nothing, can return. It's as if the very fabric of space-time, that fundamental tapestry of reality, curves so dramatically and extremely that it creates a cosmic slide with no return, a unidirectional ramp to infinity. But before crossing this invisible demarcation line, Something extraordinary and beautiful happens. Matter progressively accelerates, heats up to temperatures that defy our understanding, and shines with a luminous intensity that can surpass the combined brightness of entire galaxies. This process is known as accretion, and it represents one of the most magnificent spectacles the universe can offer. Imagine a cosmic whirlpool where matter particles dance in a hypnotic spiral, gradually accelerating to speeds near light speed, heating up to millions of degrees, emitting radiation across all frequencies of the electromagnetic spectrum. It's a cosmic ballet of indescribable beauty, where the most fundamental physics transforms into pure art. Have you ever contemplated the Milky Way on a truly dark night, far from the light pollution of modern civilization? Have you seen that whitish and majestic band that stretches across the celestial dome like a river of stars, like a luminous bridge connecting the horizons? That vision that our ancestors knew intimately and which today, unfortunately, has become rare for most of humanity? In the absolute heart of our galaxy, situated approximately 26,000 light-years away from our small solar system, resides a slumbering giant of almost incomprehensible proportions, Sagittarius A*, a supermassive black hole that contains within it the mass equivalent to 4 million suns like ours. But this cosmic giant is not a senseless destroyer wandering through the cosmos. It is a supreme architect, a cosmic engineer working on a scale that transcends our boldest imagination. Like an invisible maestro conducting a cosmic orchestra of unimaginable complexity, it meticulously coordinates the movement of hundreds of billions of stars, maintaining the elegant and majestic spiral structure of our galaxy. Without its dominant gravitational presence, the Milky Way would be merely a chaotic collection of stars wandering aimlessly through intergalactic space, without the majestic and organized form we know and admire. Think of this as a cosmic sculptor working on a temporal scale that completely defies our limited human understanding. While you live your precious lives in decades, experiencing time as a succession of familiar moments, these invisible artists of the cosmos shape entire galaxies over billions of years, creating structures of beauty and complexity that rival any conceivable work of art. Each star that majestically orbits the galactic center is like a musical note in a cosmic symphony that never ends, an eternal composition that unfolds through geological eras, and the central black hole is the fundamental tuning fork that gives the tone, rhythm, and harmony to this entire universal composition. The most recent and sophisticated astronomical observations reveal a fundamental truth about cosmic architecture. Practically all large and mature galaxies possess a supermassive black hole at their geometric and gravitational center. This is not a fortuitous cosmic coincidence. It is a fundamental partnership, a cosmic symbiosis that was established since the nebulous beginnings of the universe, when the first structures began to condense from primordial chaos. Black holes and galaxies grow together in an intimate and prolonged dance that determines the final destiny of trillions of stars. When two supermassive black holes meet, a majestic event that happens when entire galaxies collide on a timescale spanning hundreds of millions of years, they don't annihilate each other in a destructive explosion. On the contrary, they execute a gravitational dance of supreme elegance that can last millions of years, gradually approaching in a hypnotic spiral that culminates in a spectacular merger. This final moment, this cosmic union, releases more pure energy and gravitational waves than all the stars in the observable universe emit in light during the same period. There is something deeply paradoxical and philosophically fascinating about the fundamental nature of black holes. Objects that, by definition, cannot directly emit light are among the most luminous and energetic phenomena in the entire observable universe. How is this apparent contradiction possible? How can something that imprisons even light be responsible for some of the brightest spectacles in the cosmos? The answer lies in one of the most beautiful and elegant demonstrations of cosmic physics in action. Quasars, those cosmic lighthouses that can be seen across billions of light-years of intergalactic space. Imagine a majestic disk of matter spinning incessantly around a supermassive black hole like a cosmic vinyl record playing the music of the spheres. This material, composed of gas, cosmic dust, and stellar debris, progressively heats up to temperatures of millions of degrees as it spirals inexorably toward the event horizon. This accretion disk, as astronomers technically call it, shines with a luminous intensity that can be detected and observed at distances of billions of light years, crossing the vastness of intergalactic space to reach our terrestrial telescopes. It's as if the black hole were a supreme cosmic artist, using the matter around it as luminous paint to create the most spectacular and grandiose works of art in the universe. But the story of cosmic light doesn't end with accretion disks. Some supermassive black holes, particularly those that are actively feeding on large amounts of matter, create something even more dramatic and impressive: relativistic jets. Imagine cosmic cannons of unimaginable proportions firing pure energy in a specific direction at speeds that dangerously approach light speed, extending hundreds of thousands of light years through intergalactic space like luminous swords, cutting through the fabric of the cosmos. These jets are like supreme cosmic lighthouses that can be detected throughout practically the entire observable universe, announcing the presence of their invisible creators across distances that transcend our everyday understanding. The physical mechanism behind these jets still intrigues and fascinates the world's brightest scientists, but we know it's intimately related to the intense and complex magnetic fields that naturally form around rotating black holes. It's as if spacetime itself transforms into a giant and efficient dynamo, methodically converting pure gravitational energy into magnetic energy, and finally into electromagnetic radiation that travels through the cosmos carrying information about its exotic origin. These extraordinary phenomena transform black holes from simple astronomical objects into true complex and self-regulating cosmic ecosystems. They actively regulate the temperature of the intergalactic medium, directly influence the formation of new stars in distant regions of space, and determine the fundamental chemical composition of vast regions of the universe. They are like cosmic thermostats, maintaining the delicate balance necessary for the continued evolution of the cosmos. To truly understand black holes in all their cosmic magnificence, we need to courageously abandon our everyday intuition about the nature of space and time. These familiar notions, which seem so solid and immutable in our daily experience, are actually much more fluid and malleable than our limited perception can suggest. Imagine a giant elastic bed stretched perfectly, smooth and uniform like a horizontal mirror. Now visualize a bowling ball being delicately placed in the center of this elastic surface. The fabric curves dramatically, creating a gravitational well that inevitably influences the movement of any smaller object that comes to roll over the deformed surface. This is the poetic and visual essence of Einstein's revolutionary theory of general relativity. Mass and energy actively curve the fundamental fabric of spacetime. Black holes represent extreme and extraordinary curves in this fundamental cosmic fabric. They create distortions so deep and dramatic that they fundamentally alter the very nature of space and time in their immediate vicinity. Near the event horizon, that invisible but absolutely real boundary, time literally slows down measurably relative to the rest of the universe. If you could magically observe someone slowly falling toward a black hole, you would see that person gradually decelerating until appearing completely frozen in time, their image progressively disappearing as the light they emit stretches to increasingly longer wavelengths, redshifting until completely disappearing from visual perception. But here is where physics becomes almost indistinguishable from the most sublime: poetry. Black holes don't just passively curve spacetime, they do so in ways that can, theoretically, connect extremely distant regions of the universe through dimensional shortcuts. The most visionary theoretical physicists seriously speculate about the possibility of gravitational bridges, microscopic tunnels through spacetime that could, in principle, allow instantaneous travel between points separated by unimaginable cosmic distances. These hypothetical structures, known as wormholes, could be the universe's natural portals, connecting not just distant regions of our cosmos, but possibly even completely different parallel universes. This extreme curvature of spacetime also produces effects that fundamentally challenge our everyday understanding of causality and temporal sequence. Near the event horizon, the possible trajectories of matter and energy become so limited and constrained that there is literally only one possible direction in spacetime: inward, toward the center of the black hole. It's as if the very concept of outward ceases to exist mathematically in this extraordinary region of spacetime. The very geometry of the cosmos folds upon itself in ways that transform our basic understanding of physical reality. In September 2015, in a moment that will be remembered as one of the most extraordinary milestones in the history of human science, humanity witnessed something that Einstein had theoretically predicted a century before, but that few believed could be detected in practice. Two gigantic and incredibly sensitive detectors, each with precision arms of 4 kilometers in length, captured for the first time in history gravitational waves, almost imperceptible disturbances in the very fundamental fabric of spacetime caused by the catastrophic merger of 2 black holes, occurring more than 1 billion light-years away from Earth. Imagine 2 stones being thrown simultaneously into a perfectly calm and mirrored lake. The concentric waves that elegantly propagate across the water's surface are a simplified, but useful visual analogy of what happens when 2 black holes collide in a final dance of mutual annihilation. Except that, in this cosmic case, the waves are real and measurable distortions in spacetime that travel exactly at light speed, alternately contracting and expanding the physical distances between objects, making the universe's very standard meter oscillate rhythmically like the strings of a cosmic musical instrument. These gravitational waves are so subtle and delicate that they alter the distances between the ultra-precise mirrors of the detectors by an infinitesimal fraction of the size of a proton, one of matter's smallest particles. To put this in perspective, it's like detecting a variation in the distance between Earth and the nearest star by less than the width of a human hair. The technological precision necessary for this measurement represents one of the greatest triumphs of human engineering and experimental physics, requiring the development of technologies so advanced they seemed like science fiction just a few decades ago. But what gravitational waves reveal to us about black holes is even more fascinating than the technological feat of their detection. They tell us an epic and detailed story, the narrative of 2 objects that gravitationally danced around each other for billions of years, gradually losing energy through the emission of gravitational waves, inexorably approaching until, in the final dramatic instance, they accelerated to speeds near light speed before merging into a single, even more massive and powerful entity. This historic detection opened a completely new window for observing and understanding the universe. Before this revolutionary moment, we depended exclusively on electromagnetic radiation, visible light, X-rays, radio waves, to study the cosmos. Now, we can literally hear the universe through gravitational waves, detecting events that are completely invisible to light but that release more pure energy than all the stars in the observable universe combined emit during the same period. It's as if we had suddenly acquired a new cosmic sense, a new way of perceiving the reality that surrounds us. Contrary to the widespread popular perception, which sees black holes primarily as agents of cosmic destruction, they are also, and perhaps more fundamentally, active and prolific creators. In their immediate vicinity, the extreme conditions of temperature, pressure, and magnetic field create unique natural laboratories where new chemical elements are forged through exotic nuclear processes, where stars can be born in ways completely impossible in other more tranquil regions of the universe, and where cosmic complexity itself finds fertile ground to flourish. The relativistic jets of supermassive black holes, which I mentioned earlier as cosmic lighthouses, are actually much more than simple displays of light and energy. They function as cosmic seeds of creation, spreading material and energy across intergalactic distances. When these powerful jets collide with primordial gas clouds in the intergalactic medium, they dramatically compress and heat the material, creating the physical conditions necessary for gravitational collapse that will give birth to a new generation of stars. It's as if black holes were supreme cosmic gardeners, methodically spreading seeds of light and life through the vastness of space, cultivating new stellar systems in regions that would otherwise remain sterile and dark. But there is much more to the story of cosmic creation. The accretion disks around black holes are extraordinary furnaces where heavy elements are processed, transmuted, and redistributed throughout the cosmos. The iron that flows in your blood, giving it its characteristic red color, the calcium that strengthens your bones, the oxygen you breathe every moment, All these elements fundamental to life were originally forged in the nuclear interior of stars and subsequently processed in the extreme and exotic environments around black holes before being generously scattered throughout the cosmos through stellar explosions and relativistic jets. Black holes also exercise a crucial regulatory function in stellar formation on entire galactic scales. When they are particularly active, voraciously feeding on large amounts of matter, their energetic jets and powerful winds can temporarily prevent intergalactic gas from condensing to form new stars. When they are relatively dormant, in periods of lesser activity, they allow stellar formation to proceed without significant obstacles. It's a sophisticated self-regulation mechanism that maintains galaxies in delicate dynamic equilibrium over billions of years, ensuring they don't consume all their stellar fuel in a single explosive generation. This cosmic regulation is so precise and consistent that astronomers have discovered a direct and surprising mathematical correlation between the mass of central black holes and the fundamental properties of the galaxies that host them. It's as if there were constant and subtle communication between these invisible giants and the hundreds of billions of stars that surround them, a cosmic conversation that unfolds across geological timescales. Black holes inevitably confront us with some of the deepest and most philosophically disturbing paradoxes of modern physics. One of them, technically known as the information paradox, questions the very nature of reality and permanence. If a black hole eventually evaporates completely through Hawking radiation, a subtle quantum process that Stephen Hawking theoretically predicted through extraordinarily sophisticated calculations, what exactly happens to all the information contained in all the matter that fell into it throughout its millennial existence? Imagine a book being deliberately thrown into a black hole. According to the fundamental principles of quantum mechanics, all the information contained in the book, the precise position and momentum of each individual atom, each carefully written word, each expressed idea, each preserved thought, must be preserved somehow in the universe. Information, according to our current understanding of physics, is indestructible and eternal. But how can this complex information be recovered if the black hole eventually disappears in apparently random and structureless radiation? This fundamental paradox has led to some of the boldest and most creative speculations in contemporary theoretical physics. Some visionary scientists propose that all information is systematically encoded on the two-dimensional surface of the event horizon, in a kind of cosmic hologram that preserves all the details of the three-dimensional interior in a lower dimensional boundary. It's as if the universe were fundamentally holographic, with all the information of a volume being encoded on its surface. Other theoretical physicists suggest even more exotic possibilities, that black holes may be portals or bridges to completely different regions of spacetime, preserving information through dimensional connections that transcend our normal spatial understanding. Some speculate about parallel universes, extra dimensions, or alternative realities where information persists even when the original black hole disappears from our observable cosmos. The definitive resolution of this paradox may require a fundamental revolution in our understanding of the basic nature of reality. It may be that spacetime itself is just an emergent illusion, a useful but incomplete approximation of something much stranger and more wonderful than our physical intuition can imagine. Perhaps true reality is composed of pure information, with matter and energy being only superficial manifestations of deeper informational patterns. These questions inevitably lead us to the absolute frontiers of human knowledge, where the most sophisticated mathematics meets the deepest philosophy, and where our scientific understanding of the universe transforms into a form of cosmic poetry. Black holes are not just astronomical objects, they are windows into the most fundamental mysteries of existence, mirrors that reflect questions about the nature of reality, consciousness, and meaning. There is something deeply poetic and philosophically touching about how black holes intimately connect us with the deepest history of the cosmos. Each photon of light we detect from distant quasars, each gravitational wave we capture from black hole mergers in remote galaxies are authentic messages from the deep past of the universe, cosmic letters that have traveled through billions of years of space and time before arriving at our terrestrial instruments. Some of these luminous signals have traveled for periods so long that they began their journey when the universe had only a fraction of its current age, carrying precious information about epochs when the cosmos was young, turbulent and profoundly different from the mature universe we know today. When we observe a quasar situated 10 billion light-years away, we are literally seeing how the universe was when it had only a few billion years of age, a cosmic child compared to its current 14 billion years. In that primordial era, galaxies were forming much more rapidly than today. Supermassive black holes were growing voraciously by feeding on vast amounts of primordial matter, and the cosmos was a much more turbulent, energetic, and dynamically active place than the relatively tranquil universe we observe in our local cosmic neighborhood. These ancient black holes function as true cosmic fossil records, preserving in their mass, rotation, and physical properties the exact conditions that existed when the universe was emerging from its nebulous infancy. Each measurement we make of these distant and ancient objects is like carefully reading a page from the monumental book of universal history, deciphering the secrets of epochs that preceded the formation of our solar system by billions of years. But black holes are not just passive witnesses to cosmic history. They were and continue to be active protagonists that fundamentally shaped the course of the universe's evolution. The first supermassive black holes dramatically accelerated the formation of the first galaxies, created the first bright quasars that ionized neutral intergalactic hydrogen, and established the architectural patterns of growth and evolution that we still observe and study today in contemporary galaxies. It is deeply humbling and inspiring to realize that our own existence is intimately connected, in ways we are only beginning to understand, with these invisible cosmic giants. The chemical elements that compose our bodies were processed in environments directly influenced by black holes. The elegant spiral structure of the galaxy we proudly call home has its fundamental architecture determined by the supermassive black hole that silently resides at its geometric center. We are, in a very literal and scientific sense, children of the stars and grandchildren of black holes, final products of cosmic processes that extend through billions of years of universal evolution. Black holes unquestionably represent some of the most extreme and physically challenging environments that nature can create throughout the observable universe. In the immediate vicinity of the event horizon, where reality becomes almost surreal, the fundamental laws of physics are tested and explored under conditions we could never artificially replicate in any terrestrial laboratory. No matter how advanced our technology becomes, temperatures of millions of degrees, magnetic fields trillions of times more intense than Earth's relatively modest magnetic field, and velocities that asymptotically approach light speed create unique natural laboratories where the very limits of known physics are systematically explored and tested. These extreme environments allow us to rigorously test theories that would otherwise forever remain merely elegant mathematical speculations confined to university blackboards. Einstein's general relativity, for example, makes very specific and measurable predictions about how spacetime should behave near black holes, how light should curve when passing through intense gravitational fields, and how time should dilate in regions of high curvature. Each astronomical observation we make is simultaneously a rigorous test of these theoretical predictions. And so far, remarkably and consistently, Einstein has passed all tests with precision that borders on the miraculous. But black holes also inevitably take us to the absolute limits of currently known and understood physics. When we try to mathematically describe what happens at the geometric center of a black hole, the gravitational singularity, our most sophisticated mathematics simply fails spectacularly. The most fundamental equations of general relativity produce infinite values, a clear and unequivocal sign that our current understanding is fundamentally incomplete. It's likely that the definitive solution will require a revolutionary new theory that harmoniously unifies general relativity with quantum mechanics, two pillars of modern physics that, until now, stubbornly resist all attempts at integration. This epic quest for a theory of everything is one of the great questions of modern physics, perhaps the central question that will define the next century of scientific progress. Black holes may very well be the fundamental key to this long-sought unification. providing experimental clues about how the continuous fabric of spacetime behaves at the smallest possible quantum scale. They are like supreme cosmic teachers, patiently teaching us about the most fundamental laws of reality through their own extraordinary and extreme existence. The physics of black holes has also led us to surprising and philosophically profound discoveries about the nature of information, entropy, and the very structure of reality. Stephen Hawking demonstrated that black holes possess measurable temperature and well-defined entropy, properties we normally associate exclusively with conventional thermodynamic systems. This suggests a deep and still mysterious connection between gravity, thermodynamics, and information theory that we are only beginning to understand and explore. One of the most fascinating and romantically poetic discoveries of recent years is the revelation that black holes rarely exist in solitary isolation. They frequently form complex binary systems, gravitationally dancing around each other in a cosmic waltz of supreme elegance that can persist for billions of years. These binary systems are like cosmic clocks of incomparable precision, their orbits gradually and predictably decaying as they systematically lose energy through the continuous emission of gravitational waves that propagate through the fabric of spacetime. Imagine two masterful dancers on an infinite cosmic dance floor, gradually approaching over eons, their dance becoming progressively faster, more intense, more passionate, until culminating in a final embrace of mutual annihilation. This is precisely what happens with binary black holes over timescales that completely transcend our human experience. For millions or billions of years, they orbit each other in increasingly tight elliptical trajectories, losing gravitational energy extremely gradually and predictably. In the final dramatic instance of their cosmic dance, they accelerate to relativistic speeds near light speed before merging into a single, even larger and more massive entity. This final merger represents one of the most energetic events the universe can produce. In a matter of a few terrestrial seconds, it releases more pure energy and gravitational waves than all the light simultaneously produced by all the stars in the observable universe combined. It's as if the entire cosmos trembled and vibrated with the epic force of this gravitational encounter, sending ripples in the fabric of spacetime that propagate in all directions at light speed. But the final product of this cosmic merger is not simply a larger mass black hole. It is an object that carries with it the complete and detailed memory of its dual origin. Its specific rotation, its precise mass, even small transient oscillations in its geometric shape, tell the epic story of the gravitational dance that led to its creation. It's as if each black hole were a cosmic library, preserving in its physical structure the complete narrative of all the mergers that contributed to its current existence. These binary systems also teach us fundamental lessons about the long-term evolution of galaxies. When two galaxies collide on a timescale of hundreds of millions of years, their central black holes eventually form a binary pair that evolves according to the relentless laws of gravitation. The subsequent evolution of this binary pair profoundly influences the fate of both galaxies, determining whether they merge smoothly into a single elliptical galaxy or whether their nuclei are violently ejected during the traumatic merger process. The detection of gravitational waves has opened a completely new window for observing and studying these cosmic phenomena. Now we can directly hear these mergers happening in real time, detecting events that occur billions of light years away with millisecond temporal precision. It's as if we had suddenly developed a new cosmic sense, a new way of perceiving and understanding the universe that surrounds us. Black holes play an absolutely crucial and sophisticated role in the delicate regulation of stellar formation throughout the observable universe. They are, in a deeply appropriate analogy, like supreme cosmic gardeners, carefully determining where and when new stars can be born, controlling the rhythm of stellar creation through physical mechanisms of extraordinary elegance and complexity. When a supermassive black hole is particularly active, voraciously feeding on large amounts of available matter, it can completely prevent the formation of new stars in its host galaxy through processes that operate on entire galactic scales. This happens through a fascinating process technically known as active galactic nucleus feedback. The relativistic jets and powerful winds produced by the active black hole dramatically heat, the intergalactic gas to temperatures so high that it simply cannot gravitationally condense to form the dense clouds necessary for the birth of new stars. It's as if the black hole were literally blowing the essential stellar fuel away from the galaxy, creating a temporarily sterile environment where stellar formation is systematically suppressed. But this process is not destructive in the traditional and simplistic sense. It is fundamentally regulatory and necessary for the long-term health of galaxies. Without this self-regulatory feedback, galaxies would grow completely uncontrollably, consuming all available gas in a single explosive generation of stellar formation, leaving them subsequently sterile and unable to sustain life for billions of years. The central black hole acts as a sophisticated cosmic thermostat, maintaining its host galaxy in delicate dynamic equilibrium and ensuring it can continue forming stars sustainably for periods extending throughout the age of the universe. This cosmic regulation is so precise and consistent that there exists a direct and surprising mathematical correlation between the mass of the central black hole and practically all fundamental properties of the host galaxy. Larger galaxies invariably have more massive central black holes, in a proportion that remains remarkably constant throughout the observable universe, regardless of the galaxy's age, type, or location. It's as if there were constant and subtle communication between the invisible black hole and the hundreds of billions of stars that surround it. A cosmic conversation that unfolds across geological timescales. Black holes also profoundly influence stellar formation through an even more subtle and sophisticated process, the systematic redistribution of heavy elements throughout the cosmos. When matter falls into a black hole, it is heated to extreme temperatures and processed through nuclear reactions that don't occur in any other natural environment in the universe. The elements resulting from these exotic processes are then generously scattered through intergalactic space via relativistic jets and stellar winds, enriching the cosmic medium with the heavy materials necessary for the formation of rocky planets and, eventually, for the development of life as we know it. Without this cosmic distribution of heavy elements orchestrated by black holes, the universe would remain composed almost exclusively of primordial hydrogen and helium, incapable of forming the complex structures necessary for life. Black holes are, therefore, not just regulators of stellar formation, but also the fundamental architects of the chemical complexity that makes life possible. One of the most extraordinary and philosophically provocative speculations about black holes is the intriguing possibility that they might function as bridges or portals to completely different regions of spacetime, connecting parts of the universe that are separated by unimaginable distances, or even linking our cosmos to completely distinct parallel universes. The elegant mathematics of Einstein's general relativity allows theoretical solutions that connect different regions of spacetime through structures known as Einstein-Rosen bridges, geometric constructions that we popularly know as wormholes, hyperdimensional tunnels through the fabric of reality. Imagine a sheet of paper representing the two-dimensional fabric of spacetime. If you carefully folded this sheet upon itself and made a small tunnel connecting two regions that, on the flat surface, were separated by a great distance, you would have a perfect visual analogy of how a wormhole would theoretically function. Traveling through this dimensional tunnel, it would be possible, in principle, to go instantaneously from one part of the universe to another, even if the two regions were originally separated by billions of light-years of intergalactic space. Although the existence of traversable wormholes remains highly speculative and technically challenging, black holes provide us with valuable and empirically verifiable clues about how such exotic structures could function in practice. They unequivocally demonstrate that spacetime can be curved in extreme and dramatic ways, and that our everyday intuition about distance, connectivity, and causality may be fundamentally incorrect or, at best, drastically incomplete. Some visionary theoretical physicists propose that all black holes in the universe may be secretly connected through an invisible network of gravitational bridges that operates beyond our direct sensory perception. This revolutionary idea, technically known as quantum entanglement of black holes, suggests that the interior of different black holes may be mathematically the same geometric space. Seen simply from different and complementary perspectives, These bold speculations inevitably lead us to deep and philosophically disturbing questions about the fundamental nature of physical reality. If spacetime is really more connected and interlinked than our everyday experience suggests, if cosmic distances are illusions created by our limited three-dimensional perspective, then black holes may be the master keys to understanding the true multidimensional architecture of the cosmos. The possibility of travel through wormholes also raises fascinating questions about causality and free will. If it were possible to travel instantaneously through space, or even travel backward in time through specific configurations of curved spacetime, this could create temporal paradoxes that would challenge our basic understanding of cause and effect. Black holes may be the natural guardians that protect the causal consistency of the universe, preventing violations of the fundamental laws of physics through mechanisms we don't yet fully understand. As we philosophically contemplate the distant and inevitable future of the universe, extending our imagination through trillions of years into the future, black holes emerge as the probable supreme and ultimate heirs of the cosmos. While stars will eventually exhaust all their nuclear fuel through fusion processes that sustain their luminosity for billions of years, and while galaxies will inexorably drift apart from each other due to accelerated cosmic expansion, black holes will continue existing undisturbed, growing slowly but systematically through the gradual absorption of matter and energy dispersed through intergalactic space. But even these apparently eternal giants are not truly immortal. Stephen Hawking demonstrated, through quantum calculations of extraordinary sophistication, that all black holes emit radiation due to subtle quantum effects that occur in the vicinity of the event horizon, and this Hawking radiation gradually reduces their mass over periods of time that completely transcend our capacity for temporal understanding. A black hole with the mass of our Sun would take approximately 67 years to completely evaporate, a number so astronomical that the current age of the universe, of mere 14 billion years, seems like a blink of an eye in comparison. During this extremely slow process of quantum evaporation, black holes will gradually become hotter as they lose mass, ending their epic lives in a final bright explosion of pure radiation. These will be the last fireworks of the universe, the final size of energy in a cosmic epic when the cosmos inexorably approaches thermal death, when all usable energy will have been uniformly dispersed through infinitely expanding space. But even in this apparently melancholic and inevitable scenario, black holes offer a peculiar form of cosmic hope. They may be the fundamental mechanisms through which complex information and even primitive forms of consciousness are preserved through the most desolate cosmic eras. Some theorists boldly speculate that the final evaporation of black holes may give rise to new universes, through quantum processes we don't yet understand, in a kind of perpetual cosmic rebirth that perpetuates existence through infinite cycles of destruction and recreation. Black holes may also be the architects and protectors of completely alien and unimaginable forms of life. Near the event horizon, where time dilates extremely relative to the rest of the universe, entire civilizations could theoretically exist and flourish in an infinitesimal fraction of a second of our reference time, experiencing complete subjective eternities while the outer universe ages and transforms. They could be the last refuges of consciousness and complexity in a cosmos in terminal decline, preserving the essence of conscious experience far beyond what would be possible in any other cosmic environment. These speculative possibilities remind us that the universe is much stranger, richer in possibilities, and more deeply mysterious than our limited imagination can initially conceive. Black holes are not just exotic astronomical objects. They may be the final guardians of cosmic meaning, the ultimate preservers of complexity and a reality that would otherwise tend inexorably toward uniformity and simplicity. We gently arrive at the end of our epic journey through the mysterious and fascinating domains of black holes. But the profound story I have shared with you is only the beginning of an exploration that can extend through a lifetime of contemplation and discovery. Each new scientific discovery reveals even vaster horizons of cosmic mysteries. Each answer we find through our scientific investigation inevitably generates 10 new questions that are even deeper and more provocative. Black holes are like supreme cosmic cones, enigmas of mathematical elegance that force us to question and re-examine our most basic and fundamental assumptions about the nature of reality, time, space, and existence. They teach us with infinite cosmic patience that the universe is immeasurably stranger, more beautiful, and more wonderful than our initial imagination, limited by everyday experience, could ever conceive. They are not merely passive astronomical objects floating in the void. They are active cosmic teachers, supreme artists, visionary architects, and silent guardians of the deepest secrets of universal existence. They connect the infinitely large with the infinitesimally small, the most remote past with the most distant future, the most rigorous physics with the most speculative philosophy, the most precise science with the most sublime poetry. When we look at the night sky on a clear night and contemplate the apparently infinite vastness of the cosmos, let us always remember that we are intimately and fundamentally connected to these invisible giants that inhabit the depths of spacetime. The atoms that compose our physical bodies were originally forged in stellar nuclear furnaces directly or indirectly influenced by black holes. The majestic spiral structure of the galaxy we proudly inhabit has its fundamental architecture determined by the supermassive black hole that patiently resides at its geometric center. We are, in a very literal and scientific sense, part of the same cosmic tapestry that includes these extraordinary objects. Black holes constantly remind us that we are simultaneously insignificant and extraordinary on a cosmic scale. Insignificant when measured against the vastness of the universe and the energies it contains, but extraordinary in our unique capacity to understand, appreciate, and find meaning in the sublime beauty of the cosmos. They show us that nature operates with a mathematical elegance that completely transcends our everyday sensory experience, but that we can, through rigorous science and disciplined imagination, touch these profound truths and participate in universal understanding. As you return to your everyday lives, to your relationships, to your terrestrial responsibilities and dreams, always carry with you this sense of cosmic wonder that we have cultivated together on this starlit night. Remember that you live in a universe where the impossible is routine, where beauty and mystery coexist harmoniously on scales that range from the subatomic to the supergalactic. Black holes are just one of the many wonders that await our discovery and contemplation in the depths of the cosmos. And perhaps, on a particularly clear night when you look at the stars with eyes renewed by knowledge, you might hear the distant echo of that eternal cosmic dance, the almost inaudible whisper of gravitational waves propagating through the fabric of space-time, the ancient murmur of distant quasars telling stories of long-forgotten epochs, the silent but omnipresent music of black holes patiently shaping the destiny of the cosmos through countless eons. For you are an integral part of this majestic cosmic symphony, conscious and self-conscious notes in a musical composition that extends through space and time, connecting all things in a fundamental unity that is simultaneously mysterious and comforting. The universe is truly vast beyond any human measure, and black holes are its secret and silent masters, not indiscriminate destroyers but patient and sophisticated creators. Not apocalyptic endings but beginnings full of possibilities. Not sterile voids but infinite plenitudes waiting patiently to be understood, appreciated, and celebrated. And in this gradual and ever-growing understanding, we find not just scientific knowledge, but also a deep and lasting sense of belonging to the cosmos that gave us birth, sustains us, and will eventually receive us back into its eternal embrace. The journey of discovery continues infinitely, and each step we take brings us closer to understanding that we are, all of us, children of the stars and heirs to the cosmic mysteries that black holes so eloquently represent.